Hi there, TOPDON kindly sent me this jump starter for review. It is the JumpSurge JS1200. I'm not paid for the video, but since I'm allowed to keep the jump starter, I mark it as a promotion. From previous reviews, you know that this doesn't stop me from sharing all my findings with you. It is rated at 37 watt-hours or 10,000 milliamp hours and supposed to provide up to 1200 amps for starting petrol engines up to 6.5 liters or diesel engines up to 4 liters. Pretty potent stuff. As you can see, lots of protection is built in and very reassuring. It has a few more tricks up its sleeve besides jump starting your car. Basically, it can act as a power bank with a flashlight, a 12-volt DC output for powering all sorts of things, and 2 standard USB ports to charge phones or similar devices. The charge port for the unit itself is USB-C and it can charge up to 3 amps at 5 volts or 2 amps at 9 volts. Inside the box is a nice nylon bag. Within the bag is the JS1200 and a manual, an adapter with 2 clamps for the car battery, and the USB charge lead. Holding the power button down long turns the flashlight on. It's pretty powerful. Other than that, it has a strobing mode or blink SOS. There's just one button on the JS1200, a short press turns it on. Once on, you have about 8 seconds to connect a load before it turns itself off again. But if there's a load, the only way to turn the unit back off is to disconnect the load. Pressing the JS1200 power button itself has no effect. The front flap protects the 2 USB ports and a special port for the jump start adapter that has 2 high power connectors and 1 additional tiny pin. The flap on the right side contains a 12-volt DC barrel connector. A 5.5mm one fits, center pin is positive. The flap on the left side contains the USB charging port. It charges with no problems, of course, from a USB charger, and if the charger supports it, it ramps up to 9 volts and slightly above 2 amps for a quicker charge. To jumpstart a car, you need to plug in the adapter with the 2 clamps. That adapter has 2 lights, a red and a green one, and a boost button. The red light comes on if you accidentally reverse the clamps and the polarity protection is activated. A steady green light indicates you can start the car. A blinking green light means the battery is so weak you should press the boost button first and then quickly start the car. Plugging the adapter in automatically activates the main unit. I connected a power supply to the clamps to test the green light. If the voltage is below 9 volts, the green light blinks but goes steady at voltages above 9 volt. Disconnecting the power supply and then pressing boost shows that the fully charged unit is putting 16 volts into the clamp. That explains the warning that you should not do this when not connected to a battery. Imagine you would now accidentally shorten the clamps. To limit that danger, the unit automatically turns boost off after 20 seconds. I connected the clamps across a 1 ohm resistor. Well, considering the cable resistance, it's a bit more than 1 ohm. Pressing boost shows a current of 13 amps at 15.4 volts, which is 200 watts, and my poor 100 watt resistor is getting extremely hot in a hurry, despite the heatsink you see just in the upper left corner. I had to disconnect the clamp quickly to avoid serious damage. And speaking of clamps, these certainly look like they mean business. The main lead is crimped to one jaw and a jumper lead goes across to the other jaw, so both deliver current. The metal of the clamps is apparently copper-coated steel because a magnet definitely sticks to it. Maybe pure copper would be mechanically too weak. Of course, I tested the unit with my car, although it doesn't need a jump start. I used the clamp meter to measure the current. It is set to its highest range of 100 amp DC. The green light is steady, no boost needed. When starting, the meter overloads immediately and then shows a quickly declining current. All I can say that the JS1200 definitely is able to deliver in excess of 100 amps, but that's as far as I can measure its performance when starting a car. Let's move on to things I'm more equipped to measure, starting with the USB ports. It has 2 ports, but they are so close together that I have to use an extender for my second USB tester. Both ports are running and delivering 5 volts 1 amp no problem. There's a bit of a drop for the yellow tester because it has an extra extender cable and connector resistance. Switching both to 2 amps and the resistors are getting very hot, but the JS1200 has no problem delivering the power. Testing the JS1200 USB delivery using a board that can command different voltages and my electronic load. Ramping up the current and going to 3 amps as specified is no problem. The overcurrent protection finally shuts the port down at 3.4 amps. Doing the same test for 9 volts and ramping up to the specified 2 amps works fine. I can push even 2.3 amps and only exceeding this causes a shutdown. And now for 12 volts, ramping up to the max of 1.5 amps works fine. At 1.9 amps the voltage starts to sag a little and the shutdown happens at slightly over 2 amps. And finally a quick test if the 2 ports can deliver different voltages, and yes they can, no problems. This works all very nicely. Next, the 12 volt port. According to the manual you can draw up to 10 amps. In this test the left meter is showing the voltage and the right one the current. I use my electronic load to ramp up the current. At 4.3 amps my electronic load refuses to increase the current further because it is at its 60 watt max limit. I considered buying a bunch of car light bulbs for more tests, but based on the previous runs I don't have any doubts that the JS1200 would meet the 10 amp. I did a capacity test using the USB port, recording the voltage, current, milliamp hours and milliwatt hours. From fully charged to shutdown, the JS1200 delivered 2 amps for slightly more than 3.4 hours. The recorded capacity was 6,856 milliamp hours, which is lower than the 10,000 milliamp hours battery capacity specified. I guess this is because the DC conversion is not lossless. Some of the milliamps from the batteries were used by the JS1200 and not delivered to the output. Using a different load current or USB voltage would produce different values here. More meaningful is the energy I could get out of the JS1200 in form of watt hours. 30.6 is quite a bit below the 37 advertised, but then, because of my crude setup and the relative high current for USB, it was quite a voltage drop of about half a volt before the voltage was recorded. You see this clearly here before the load was turned on. Also here I must have accidentally moved some cable, caused contact resistance to change slightly. Anyway, 0.5 volts times 2 amps is 1 watt, which means over 3.41 hours the result is 3.41 watt hours too low. Adding this to the result is 34 watt hours, which is a lot closer to the spec, and 3 watt hours or 8% not delivered due to conversion losses sounds about right, giving an efficiency of 92%. Doing a similar test with a 12 volt port and 1.5 amps constant load is quite interesting and revealing. Most noticeable is that the 12 volt voltage is not constant but dropping from 16.65 volts when fully charged to 12.18 volts when empty. If you divide both of these numbers by 4, you get standard lithium battery cell voltages. This means that JS1200 internally uses 4 lithium batteries that are all connected in series. This tallies with the 35.3 watt hours of energy I managed to get out of the JS1200 using the 12 volt port, because there are much fewer losses, probably just some protection circuits at work here and no DC to DC conversion is taking place. Let's have a look inside. Easy enough, I thought. There are 4 screws, 1 in each corner, but the unit would not open, and using a spudger on a device with a very powerful lithium battery is not without risks. I hunted for hidden screws under the label, but there are none. In the end I asked TOPDON and they said it's just 4 screws and clipped together. So reluctantly I used the spatula, amplified with a stubby screwdriver you see, and finally managed to pry it apart. I decided not to mess with the battery pack, but at least have a look at the PCB held with 4 screws, making very sure no screw falling accidentally inside and causing a short circuit. Lifting the PCB was not easy because of the connectors and the tight fit. There are the 2 massive cables at the bottom for the power delivery to the adapter with the clamps. The PCB does not contain all that much. There are 3 inductors visible, very likely for 3 DC to DC converters. One for boosting the USB-C voltage to charge the 4 batteries in series, and 2 for the 2 USB output ports. Some charge control and some protection circuitry. I tried to force my way into the adapter but failed. There are no visible or hidden screws, and knives and spatulas left it unimpressed. I don't want to use excessive force because I plan to keep this jump starter for our aging cars. What this unit essentially contains is either a couple of MOSFETs in parallel as a switch, or a relay to turn the power to the clamps on or off. Given that there is a distinct click, I'm guessing it's a relay. I like the TOPDON JS1200 and I'm glad to have it available if my own or our friends' cars have starting problems. The added functions like torch and USB charging, but especially the 12-volt supply, will also come in handy, no doubt. If you like my videos, don't forget to subscribe. There are more repairs and reviews coming up, and it would be great if you decided becoming a Patreon. That would really help this channel. As Patreon, you always get early access to videos, a blog and other exclusive content. Thanks for watching.